All right. Welcome back. Last class. And then we have last lecture. Let me rephrase that. And then we have test prep on Thursday, and that's it. So if you made it through online as well, congratulations. Class 11. 121 slides. Look at that. That's like one of the lower. That's low, right?
Yeah.
I know. Everyone's in class going, what? That can't be right. Has everybody read chapters 1 through 8 so far? Yeah. Sure. All right. Any questions before we get going? No? No. Yeah. Pretty laid back class, but we still have a lot to get through, so we'll get going. Start with a quiz. What type of backup is typically obtained during the response, aka containment phase of incident response? Is it an incremental, full, differential, or a binary? Well, as we walk through this, right, incremental, what's incremental? It's going to increment each time. A full is the full backup. Well, and a differential is going to be since the last full. Well, right, we know, I can tell you right now, I'm just thinking through how I'd answer this. I'm definitely not going to be an incremental or differential, right? I can immediately eliminate those two. So is it going to be a full or a binary? Well, we want to do a binary because it's incident response, right? That's at bit level or byte level backup. Hey, look at that. Huzzah. All right, I'm done. No, what is the primary goal of disaster recovery planning? Integrity of data, preservation of business capital, restoration of business processes, or safety of personnel? D, safety of personnel. That is all. If you see that, that's your gimme, right? We've talked about that as we've gone through. Safety of personnel or human life is always going to be the top priority. What business process can be used to determine the outer bound of the maximum tolerable downtime? Who remembers maximum tolerable downtime? A little bit. Right. So accounts receivable, invoicing, payroll, or shipment of goods. Well, how maximum tolerable downtime? It kind of says what it is. How long can we be down before there's severe business impact, right? Well, what's going to cause the biggest problem, impact to your business? People not getting paid, and they're not going to work for free, right? So we're going to look at payroll being a good outer bound. All right, if your maximum tolerable downtime is 48 hours, what is the most cost-effective alternate site choice? Now, this is important, cost-effective site choice, because there's multiple answers that would be correct and meet that requirement. But so when we look at this, cold site, the way I think of that is going to be, well, I started at hot. Hot or redundant is going to be real time, right? Yeah. That's how I think of it. A hot site is going to be hours. Warm site is going to be days. Cold site is going to be in the more of the weeks, right? So if we're looking at kind of, we got 48 hours, we've got a couple of days to get up. Warm site.
I thought the book listed warm is more that 3 to 7 days.
Does it say that? I thought it said.
See, warm is cheaper than hot, but hot is faster than warm.
Mm-hmm.
You only have 2 days, and you can't guarantee that you can get it up in 2 days. The most cost-effective site would be hot.
It's in between, I think.
I want to say, I thought it was for 2 to 2. It was was kind of the cutoff for hot.
Yeah, but, 2 days.
Right,
yeah.
But if you have 2 days, what's the most cost-effective? You could have it up in a warm site in 2 days. I would say warm.
So go with the cheapest?
What's going to be because it says cost-effective on there. That's the trigger on that one. Yep. What would be the cheapest?
It's really a thing. It's just the cost-effective equals cheap.
Yeah.
Warm sites is 1 to 3 days.
Yeah. Hot site, so redundant is real time. Hot site is going to be hours.
Taught in other methodologies.
What's that?
I have to forget what I was taught in other methodologies.
Yes.
ITIL, they define the warm.
Oh, yeah.
You know, 3 days or more. Hot site is 48 hours or less. And you can also have your immediate, which is your redundant or
Yep.
stable.
Yeah, ITIL is different, and I think the CISM has slightly different as well. That was the hardest part, was remembering what was what for each of those. Yeah, so redundant real time, hot is hours, right? R redundant real time, hot H hours. Warm is days, and then cold is weeks. Fortunately, that doesn't go all the way through, but it can kind of help. That's how I remembered it. All right. Structured walkthrough test is also known as what kind of a test? Checklist, a simulation, a tabletop exercise, or a walkthrough drill? Structured walkthrough is also known as a tabletop. That one I just remember. You memorize it. What type of backup will include only those files that have changed since the most recent full backup? Well, again, we can immediately get rid of full because, right? I mean, I guess technically it would be, but that's not what they're saying. A binary, we know, we just talked about being more for bit level, byte level. So differential, incremental, it's differential.
Technically, it's the first backup after the full. Both differential and incremental would pick up the files that have changed since the full.
So
But differential is everything plus the new stuff. Incremental is just the new stuff.
right. Incremental will be, well, no. Incremental is going to be,
Changed would be then incremental, not differential.
incremental is going to back up anything that's changed since the last full or incremental. And with this one, we're saying since the most recent full backup.
Include
Sure, so I don't read more into it than is there. Yeah.
Will include only those files that have changed. It would still be incremental.
Differential picks up what's changed as well, but it picks up more of them every time you run it.
Right? Yeah. So incremental is going to say if you do a full backup on Sunday, it'll back up what's changed on Monday. Then it'll only change what's backed up since Monday on Tuesday. On Wednesday, it's only going to back up what's changed since the previous backup Tuesday night. So it's going to back up just what's changed each day or between each run. A differential, you run your full on Sunday, and it's going to get everything that's changed since that full, regardless of what day of the week. So we're saying it's going to back up those files that have changed since the most recent full backup. And if it says,
No.
I
think they're a-holes because this is like a trick.
This is a definition. It's straight out of the definition on there, though. That's it. It's the most correct answer.
Right.
Yep. That's the so and what you're going through is what we'll cover Thursday to kind of get you in the mindset of how to read these questions and understand that. Because that's going to be a huge part of this is understanding what they're looking for and how to grab out of this question and know, oh, when they say that, this is what they're looking. This is the keywords to focus on. No, that's pretty. But that's what they're getting you. Yep.
I know.
There are a lot of those.
I know. I get that. The most correct answer.
All right. So left off incident management and incident response. We're going to talk about executive succession planning. So organizations must ensure there's always an executive available to make decisions during a disaster. So when you're looking at that, how many people send everybody off on the executive retreat? Who's making the calls if something happens during that time and you can't get a hold of them because they're on a cruise? Do we have a succession plan in place, right? So one of the big executive powers, ability to endorse checks and procure money. What do we talk about with maximum tolerable downtime? Payroll and making sure that you can have business continuity. How are we going to maintain and keep going? There needs to be somebody there who has the ability to make that call and has the authority to actually, endorse the check or get the money from the bank or wherever it is. So, it's very important, and we must make sure that there's somebody available at all times. Now that the plan is approved, right? Senior management approval is required for the next step. Why is that? It's the same with your security program or security policies, that senior management's responsibility at the end of the day, right? They have to protect the assets and personnel. They have to sign off on the BCP, the DRP, the IRP. Ultimately, if something happens, who's going to be responsible to answer for it? Senior management. That last one is really important, and we see that a lot where like, well, we're trying to do it, but we're not getting the support. Well, let's talk to the senior management about what their responsibilities are and kind of help them understand who's going to be answering the news and whose name's going to be splashed all over the place if there's a breach. CEO, CIO, whoever it is. Do you really not want to be involved in understanding what this is? Okay, yeah, you're right. Right. So we need to make sure we understand that ultimately senior management needs to sign off on this. And if you can get the buy-in from the start, makes your life a lot easier. More backups and availability, right? You guys didn't have enough last class, right? Yeah. We need to be able to effectively and efficiently back up and restore systems and data. We need to be able to verify recoverability. So how many people run the verifications on their backups? Everyone really should be. Yeah, it adds a little bit of time, but I don't know about you. I've had it happen where we didn't do it and dodged a bullet, where we were able to recover, but we had a backup that was corrupt. We were able to recover from a different one and still meet the recovery time point. After that, every single backup job got verification. It's not worth the stress. So we make sure we verify our backups. Critical backup media must be stored off-site. You don't want the same thing that takes out your primary site taking out all your backups. Kind of defeats the purpose of your backups. And then high-end tape drives if necessary, or so if you're backing up to tape, you need to be able to procure something to actually restore all your tapes. If you're backing up to the cloud, it would need to be appropriate pipe to download your restores, whatever that is. Tapes are, like we talked about, they're going away, but they're still out there. And then mean time to recover is greater than the maximum tolerable downtime, then you need to find a alternate solution, right? Because your mean time to repair, that's how long it's going to take. You have a tolerable downtime. If your max tolerable downtime is 48 hours and your repair and restore is going to take 72 hours, we got a problem. We need to figure out what do we have to do to either make that work, what solutions can we put in place, or is our max tolerable downtime accurate, or can they accept something longer? Typically not. So that's when you go back and ask for more budget. I need more money to make that work. No question.
I'm going to argue, Mark. I'm really mad about that last question.
Hey.
The definitions are essentially the same. One says since last full backup.
Yep.
One says since the last
Full
backup.
or incremental. Or last backup, yeah. That is, but that's a memorization. No, it's not. It's a memorization thing. You got to know the difference. Same with the different RAID levels. You just got to know when you look at that, what are they asking? All right. Hard copy data. So hard copy is reading, writing on paper rather than digital through the computer system. So do we have hard copy data backup and availability plan in place? So when you look at those emergency prone areas, Florida, Mississippi, Louisiana, paper only disaster recovery. So you'll see this also in hospitals, right? Where they're going to paper only if their ERP or whatever, EHR is down, they'll go to pencil and paper. You see all the studies about how much longer it takes to go back to pencil and paper over that. So you just need to know hard copy data is paper, reading and writing on paper, and it could be part of your disaster recovery plan to take that into account especially again flood, weather-prone areas, healthcare. I see that. We'll see it a lot where they'll have that
But isn't
in place.
healthcare required to have generators of a certain power?
They'll still have, well, because even if they have the generator, in theory, you could have an outage, right?
Well, yeah,
So they still have to have that in place to be able to,
like they didn't get enough fuel or something?
or their provider is down, the software blows up. Yeah, it's got to be more than just power, because right, you can't mess around with charting.
There's like a gas leak in the area or whatever.
They shut down.
Sure.
Yep.
No, I'm just trying to frame it.
Yep. Yeah, really, it's allowing, this line here, allowing operate key critical processes with just hard copies of data, pen and paper. So I don't remember seeing a whole lot on there. Just understand that's what if you see hard copy data, it's paper pencil instead of digital. Oh. We got our HR director walking by making faces. You mind moving that planner since we're all here now? Thank you, Peter.
I'd be happy. Sorry to interrupt, guys. Hi, guys. Thank you.
When Evan's not here, just all goes out the window. He's online, I'm sure. Anyway, so backups and availability. Oh, hey, more for you. Electronic backups. Just know it. Archives that are stored electronically, right? Easy. Full backup. Everything is copied and stored in the backup repository. What do you need to know? Time-consuming, bandwidth-intensive, resource-intensive. Right? This is going to take the most amount of space and the most amount of time. So when you're looking at the question, just understand if it says which is going to cover everything, or which backup type is the most time-intensive and resource-intensive, it's going to be a full backup. If we're looking at incremental, it's archive data that's changed since the last full or incremental. And then differential is since the last full backup, and that's where it comes into play. It's just strictly memorization and understanding that when you see that question that says what type of backup gets it since the last full, you go, oh, they're looking for differential backups. That's all it is. All right. More stuff, electronic vaulting. So this is your batch process of electronically transmitting data is backed up on a routine, regularly scheduled time interval. So backup on a daily or possibly hourly rate. Look at this being, I just went blank. It's not the database stuff where you'd see, but like if you have certain, we had certain folders that we had to back up, and we would just do like basically a job that would run, that would just copy the full files across to our DR location on every 15 minutes. It would just run. Anything new in that folder got copied. Anything new got copied because we couldn't afford more than 15 minutes of lost data. It's going to be anything that's on so electronic vaulting, batch process, so regularly scheduled on a whatever that time interval is. So yeah, it could be daily, hourly, however often you want. It's just going to be a scheduled task that's going to store your data offsite. Across the internet on most locations. Remote journaling. So that's the database journal is a log of all your database transactions. So right, you get your database and it's going to log everything that's happened. When you recover a database, you'll have your initial, your backup of your database. You do your full database backup once a night or once a day, whatever it is. And then the journal runs constantly. You can replay that journal against your last backup and get your database back to that current state. Right? So you just need to know when you're doing remote journaling, or it's going to be copying that journal to a remote location so you can get your database back up to the most current state. Okay. Shadowing is going to be 2 or more identical databases updated simultaneously. So shadowing you've got your database in location A, location B is going to be writing it to the database and B at the same time. The users are only going to see, that one database that they only think there's one, but we're actually shadowing it across. We're copying that data to the database in real time. So we're not restoring from a backup and then replaying a journal. It's copying directly those changes to that database at the remote location. Does that make sense? All right. Software escrow. So again, we talked about this with key escrow and encryption, right? Same concept. We're going to allow a neutral third party to hold the source code. So if you have concerns that a company is going to go out of business and you've got a critical application that is dependent on them, you can put the software into escrow. If they were to go bankrupt, go out of business, you would still have access to that source code. So you could still maintain and support the software that you'd paid for. All right. Easy, right? This is an easy chapter or easy night. I'm avoiding the questions online because I'm sure they're like, no, it's not. So disaster recovery, testing, training, and awareness. Yeah, as it says, skipping these is one of the most common mistakes, right? Because, we got our disaster recovery plan. We're all good. We update it once a year. Great. When's the last time you tested it? Tested it? We recover all the time. There's a difference between recovering a file or something because somebody messed up and actually stepping through and testing your plan. One of the big things, right? It's never complete. These are all living documents, right? Your organization is going to be constantly changing, threats changing, so, the environment's changing. So to test those, that's the easiest way to identify, are we missing a step? Right? You want to do it during a test, not during the actual disaster, and go, oh, well, we needed something that we don't have, or it took us an extra 6 hours to figure out this piece during a DR, and now we're going to miss our window. So by testing it and doing training on it, that's that continuous improvement of your plan, identifying holes, identifying areas for improvement. They're complex, right? Anybody recovered an Active Directory from tape? It's not fun, right? I did it in a DR environment, and it took, 36 hours to figure out and find all the stuff. The next time, it was like 8 hours. Way easier to do it and figure out all those things when, you've got some pressure, but you don't have the organization screaming at you to understand why we're not up yet. So, each member of the disaster recovery plan needs to be familiar with the particulars of their role so that when you call a disaster, people know exactly what they're expected to do. So DRP testing, huh? Oh, there we go. We're going to talk through all the stuff I just said. And I just did this slide was that last week? No, that was 2 weeks ago, wasn't it? I don't even remember. Yeah, 2 weeks ago. It's all a blur. In order to assure it, we need to, the testing is going to show it is a viable plan, right? That's an easy way to show, yep, we're good to go. We know it works. Any changes need to be included in the disaster recovery plan. One of the easy ways to do that is to make sure a member of the DR committee or the business continuity committee is also on the change committee. So any changes that come through automatically get passed through somebody who is going to keep that in mind. Ensure both the initial and continued efficiency or efficacy of the DRP, doing the different types of tests. So we're going to do a tabletop. We're going to do, the tabletop, we're just walking through it, right? Or we're going to recover to a DR environment that's segmented off, or we're going to actually do a full cutover to our DR. We'll talk through those, I think. But at a minimum, we need to do an annual test. And obviously the environment is going to play into that, right? There's different ways to make that work, but from the CISSP test, you'll need to know, right? DR testing should occur annually, regardless of the type of test being done. So here we go. Look at that. The types of testing. So a review, it's going to read through it and make sure it covers everything. We're just going to review our DR plan. At a minimum, we need to review it and read through it on an annual basis and update it where required. So, right, what are you looking for in a review? Oh, it says Exchange 2010. We're actually on 0365 now. Well, that's a catch you're going to make, right? But we're not looking at walking through those steps. We're just looking for that completeness and that we don't have major changes that are no longer valid. So DRP review, most basic form. We have a checklist. So now that's where we're going to have a list of all of our components, everything that we need to recover. And then we're going to go through and make sure that if it says we need this type of server, this much capacity for storage, this, these tapes, this, whatever it is, can we actually get that? So we're literally just going to make a checklist of all the resources we need and then go back and say, can we do this? Is it going to be available if needed? Again, kind of goes with the structured walkthrough or the tabletop. We just want to make sure that we can acquire everything we need to recover or that we think we need to recover in the appropriate amount of time. So checklist, kind of self-explanatory, I think, right? I got a checklist of what I need. Can I do it? Yes or no? Parallel processing. So this is one I've done a lot of. Basically what you're going to do is you're going to set up a system and say, I'm going to recover from, today's Tuesday, I'm going to recover from Friday's backup and process all of Tuesday's transactions against that, or all the weekend's transactions. And so when I come in Tuesday morning, it's the state of the system the same as the actual production was, right? So you'll pick a point in time and say, okay, as of this time, we're going to run our last backup, reprocess our transactions. Does everything match up? You're going to do this in a separate isolated environment, right? We're not actually touching production. So this is one we did at the bank a lot, right? We would go and say, all right, we're going to do Thursday night's backup and then process all of Friday's transactions and then look at the close of business Friday in production, what it really was, and then look at it when we rerun it in test or in the recovery situation and make sure that the close of business reports match. Can we actually, that's how we're proving our DR worked. Does that make sense? All right. And then partial or complete business interruption. This can actually be the cause of a disaster. So you might want to make sure you've got sign off at the highest level and understand that we are going to stop processing and recover at DR. And if this doesn't go right, it could take things down, or we were going to have to recover it in production in reality. So I never liked doing these because the stress is pretty high on that. So I tried to pick ones that weren't maybe as critical to show we could do it. The process would be the same, but if you can get it done, it makes you look really good. So testing is going to have you stop processing normal business at the primary and leverage the alternate computing facility. This is where you're going to have a fully redundant load balanced operation. So that's really makes the most sense. We're going to cut it off at one and start at the other. How much of a downtime can you afford to switch over? Well, typically that's going to be in the real time, that redundant situation. So, make sure you have, I did not approve you to go do complete business interruption testing. That's what they were saying at the boot camp. So we can go tell them that Brad said to do this? No. Start with the other ones first. Get the parallel processing down and have no issues with it before you go there. But know what this is. Training. So comes as part of performing the test. That's the best way to train on this, is just doing it, right? I don't know of a better way, especially when you're looking at disaster recovery, business continuity. Just doing it is, You can read through it. That's great. Anybody who's actually done restores or done any sort of thing like that, it never works like you think it is. So just training to get how that works. And you might need some more detailed on some of these specific elements. So what are we looking at for specific starting emergency power? So who's going to be trained and be in charge of testing the changeover? We need to understand that, because that's going to take specific training on that process that is typically going to be unique per organization. So again, we need to know starting emergency power, the call tree training and tests. So individuals with that call responsibility expected to be able to answer within a short period of time or otherwise make arrangements. You can do this a couple ways, right? You can hire those call tree services, or we would have a call tree. We would know at some point in this week we're going to do a call tree test, and then the expectation would be you respond with an email to whoever is organizing the test with whatever the phrase or word is that comes down from above. So that way you can kind of verify, right? At this time, I sent the email with the correct phrase. That way they know I got the call, and that whoever was calling me followed their procedures, and it goes along that way. So we need to do call tree testing and training, understand what that looks like. Awareness. So, training is specific, right, on those specific activities. Awareness is the ongoing kind of education. So even if you don't have an active role or very little active role in the recovery process, we need to understand what the organization's prioritizations are and know what our responsibilities are, no matter how low. Even a normal user is going to have a responsibility, right? If the building gets hit by a tornado, what is the user's responsibility? How do they find out where they're supposed to report? So training and educating them on their responsibility, regardless of how large or how little their active role will be. All right. More BCP and DR maintenance, right? We must keep it up to date, and the plans must keep pace with all critical business and IT changes. So how do we do that? Well, through change management, right? So that's what I mentioned right there. BCP member should be a member of the change control board. Reason being, right, change management is designed to ensure security is not adversely affected. At the same point, right, security, business continuity, disaster recovery tie into that. So as we go through the change management process, if Joe's like, yep, I'm applying this new server so that we can add capacity for, this day-to-day functionality. If I'm on the BCP or DR, I'm going to go, oh, okay, so what does that mean? Do I need to add capacity to our DR plan? Do I have enough capacity as is to run in DR? I just need to be able to be aware of those changes to the organization and how are those going to affect our business continuity or disaster recovery plans. So change management, tracking and documenting all planned changes, formal approval for substantial changes, and then documentation of the results of the completed change. All our changes must be auditable. We should have a change control board that manages it, and then BCP or DR member should be part of the change control board. So that way we can keep on top of things and not fall too far behind. It's easy, right? Last lecture, this is easy stuff. I can actually hear the people online screaming at me saying no. So what are some of the big mistakes we see? Lack of management support, right? It's really hard to say we're going to meet our requirements if I'm not getting the management support and ensuring that I'm going to get financial or resources be made available. Lack of business unit involvement. Who's setting maximum tolerable downtimes for the different applications? The business units, right? Who knows better how long this can be down before it's going to cause some sort of an impact? Well, the people using it and understanding how that works with the business. Lack of prioritization among critical staff. Yeah. Improper or overly narrow scope. So we're going to say, yep, we're going to recover our data center or we're going to recover this application, but you don't take into account that it requires Active Directory to actually work. Oh, and then Active Directory actually wants 2 domain controllers to be up to work properly because it knows that there's multiples, and if it sees itself as the only one, it throws error, right? So we need to understand what exactly is actually in scope and what all is entailed. It's oftentimes a lot larger than, yep, we just need this application to work. Well, that's great. What's supporting that application? So making sure you properly scope it. Inadequate telecom management. Yeah, do you have capacity at a DR location? Do you have some sort of failover in place so that if you're not at primary site, you actually can run? Supply chain management. Do you have contract with your server vendor or your laptop workstation vendor to say, hey, what happens? Our DR plan calls for 300 laptops at this location. We don't carry can you help us with this? Do you have anything in place? You don't do that planning ahead of time. That's not a fun conversation to have because, yeah, they'll help you for a price. It's a lot easier to figure that out ahead of time, right? Understand how are we going to get this equipment, this whatever it is that we need for our DR BCP, right? Location, things like that. Incomplete or inadequate crisis management plan, a lack of testing, and then lack of training and awareness, which we just talked about. And the biggest one is the failure to keep your BCP DR plan up to date. We see that a lot with, we've got it. It's over here, blowing off 3 inches of dust. When's the last time that was updated? 7 years ago? Probably not accurate anymore. So, some specific frameworks, if you're interested in reading it, NIST 834 and ISO 27031. So, when you look at this, you can download that and read it if you are having trouble sleeping. But ISO 27031, it focuses on business continuity plan. The DR is actually handled by a different one. Right, because remember, business continuity plan the DR plan is part of your business continuity plan. So not surprisingly, from an ISO standpoint, each is their own framework because they are separate, but they do call to each other, right? The BCP ISO 27031. I don't remember that one specifically being called out, but it's good to know. Terms from ISO 27031 is ICT, Information and Communications Technology, and ISMS, that's your Information Security Management System. So you probably won't see that. If you get ISO certified, the ISMS is a big one. How are you actually managing your security program? They try to stay fairly neutral on a lot of this on the exam, so they don't go too deep into those proprietary standards. Just good to know at a high level. The ISO plan for disaster recovery 24762 2008. You can read that if you want it, but there you go. It's there for you. The British Standard. British Standard Institute releases BS 25999, and that still just makes me laugh because I'm apparently just a teenager still. Part 1, Code of Practice. Part 2 is Specifications. So Part 1 is guidance. Part 2 is actually the standard that you're going to show in compliance. So think of that kind of similar to how ISO 27001 and 02 are. You have the guidance and then the standard, Part 1 and 2 for the British standard for the BCP DR. Business Continuity Institute, 6-step good practice guidelines. So management, you have, I think probably a good idea to just know if you see what PP1 through PP6 are policy program management, embedding business continuity, analysis, design, implementation, and validation. If you look at it, it really goes back to what we just, we talked about, right? It just makes sense. So you just make sure you understand if you see the PP3 or 4 analysis, it was the Business Continuity Institute. You don't need to know specifics about what is the analysis phase of this entail. I don't remember seeing anything like that. So there you go. There we go. Domain 7. We're done. All right. Time for a break, right? No. No. Now we're on to software development security. Hooray. So the plus is, for anybody online, I mentioned this in the class earlier, I am not a developer. And so what you're going to hear is going to be enough. You don't have to understand a huge amount of development. You just need and coding. You just need to understand what's here. It will get you past the exam. I improved. So there you go. Evan thinks this is a walk in the park. It is. It's pretty easy. And it's the last domain. Excited? We're almost done. All right. So we're going to talk about programming concepts, your application development methods, databases, object-oriented design and programming, assessing the effectiveness of software security, and artificial intelligence. Nice light chapter to end on. No? All right. Here's, as I was talking about in the when I did the boot camp, they're like, "Are you kidding me? More to memorize?" Yes. You're going to have to know these. So extreme programming. Agile development using pairs of programmers working off a detailed specification. We'll go through these things in more detail, but basically you're going to get a specification and just two people going at and working, throwing out like, oh my gosh, I've got a holiday brain. I just went completely blank. Demos, like, yeah, just like a mock-up, right? Wow, that was tough. Objects, so black box combines code and data, sends and receives messages. So you have an object, you don't really see what happens inside that object. That object, though, will contain a code to process the input and send out whatever output is appropriate. And then object-oriented programming changes your order procedural to program as a series of connected objects that communicate via messages. So we'll go through that a little bit more, but just think of objects as, right, you've got a black box that says this is what this process does in here, whatever it is, and then you can build off of that. So you'll have different processes rather than the old if-then statements, if you think like going back old school. So you don't have that procedural programming methodology. You have predefined objects that you can then build programs with.
Now, we've used object as subject and object early on. Do they throw any test questions at you that throw in, for example, they want to define object?
It would be...
They give you enough context?
Yeah, they would give you enough context that if you understand the difference, that in this development model, blah, 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 an object is what. So there will be enough context within the question to define that they're looking at this as within the development piece, as opposed to, right, the subject object being active or passive. Yep. Procedural languages using subroutines, procedures, and functions. Need to know that. Spiral model, it's development model designed to control risk. It looks like a spiral. There you go. System development lifecycle. So development model focuses on security in every phase. SDLC is security in every phase. That's kind of the key on that one. Waterfall. Application model using rigid phases. One phase ends, the next begins. Literally, think of it as like steps. Waterfall going down. You can't get to the next one until the first one completes. And we'll have some diagrams for that. It's pretty straightforward, fairly. So why are we looking at this? Programmers make 15 to 50 mistakes per 1,000 lines of code, but following a programming maturity, such as the SCI capability maturity model, they can lower that to 1 mistake per 1,000. So why is that important? How many lines of code is Microsoft's Windows? Millions, right? If you're looking at 50 mistakes per 1,000 line, that adds up, right? That's where all these bugs, that's why we're constantly seeing fixes. So even at 1 per 1,000, it's still a lot, but if we can reduce it that much, right, that's where we're talking about this. So the maturity framework is used for evaluating and improving software development process. You need to know it's developed by Carnegie Mellon. So SEI CMN by Carnegie Mellon would be important to know. The goal of that is to develop the methodical framework for creating quality software. Right. So SEI CMN by Carnegie Mellon is really meant to reduce the amount of code or errors per 1,000 lines of code. It's going to have a measurable and repeatable result. There you go. If you're really interested, you can go and see and read about that more. And that's basically what it'll look like, right? So we're looking at going from an ad hoc where they're not really going to have anything all the way up to optimized. And we'll talk through this a little bit more, but yeah. So yeah, initial, right? It's ad hoc. It's not formalized. It's informally applied tools, right? We're just doing what we got to do to make it work. Nobody ever does that, right?
Not that we're telling the auditors.
Right? Yeah. Not that we're telling the auditors. Repeatable. So we've got a process and we can repeat that. Pretty straightforward. Defined. We're now establishing that basic set of requirements and meeting those. And then managed. We're seeing quality improvements, measurement, and then optimized. We'll go through this more. All right, machine code, machine language. You'll need to know this. This is what the software is executed by the CPU. This is binary, ones and zeros. Machine code is executed by the CPU, ones and zeros. All right, source code. You'll need to know the difference between these two. Source code is the language which are written in text, which must be translated in machine code before execution. So source code is the human readable. Machine code is what is actually executed. Kind of an easy way to remember that. So that's what machine code looks like on an old Commodore. But right, it's all the hex in that case. And there's what source code looks like. That's what we're all more familiar with seeing, right? All right, got machine code versus source code. All good. See, easy. This is easy. So we'll end with this one. You guys will be like, that wasn't such a bad class. Then you'll go to take the test and do the practice questions. Like, oh, that's right. Assemblers, assembly language, low level. So when you see it, it's going to be short mnemonics, add, sub, jump, right? So assembly language is going to convert your assembly language into, assembler is going to convert assembly language into machine language. So add this, sub this, jump to, right? It's going to convert it into from what you can read in assembly language to what the machine actually executes. Compiler is going to take C or BASIC and compile it into machine code. So right, everybody had downloaded stuff and had to recompile. I see people having like PTSD. Oh, yes. So assembler is going to take assembly language to machine code. A compiler is going to take source code, C or BASIC, into machine code. Interpreter, we're going to take on the fly. So Perl, Python, Java. So every time we enter that code, it's going to interpret it from those different compiled codes on the fly every time it's run. So that's kind of the big difference between, a compiler is going to compile it and then you run it. The interpreter is going to take that compiled code and interpret it every time it's run. I think that's really all the deeper I ever went into it, and that's enough. Just understanding if they say, what is the what compiles on the fly every time the program is executed, and it's interpreter, assembler, compiler, right? So you'll just need to know enough to be able to tell the difference in these types. Bytecode, interpreted code exists in an intermediary form, converted from source code, but can be converted to machine code. So, I think for this one, Java bytecode is interpreted code in an intermediary form. So if you see intermediary form, they're going to give you something that's going to they'll trigger it. Which of the following is intermediate? It runs it from an intermediary form, or bytecode does how do you know what this is? That this is bytecode, and one of them will be it runs an intermediary form. All right, that's all I learned about it.
Does that mean that interpreted code is always open source?
No, it's just saying every time you run it. So like I said, the shell code. Every time you run it, it's compiled on the fly every time. So it's looking for whatever that input is, or something that is going to be run every time that is executed. That it has to compile as it goes, rather than you compile it once and just run the same thing every time. It's gonna compile it every time it's run. That's all it's saying. But we are going to talk about open and closed source. Don't worry, we'll get there. Know the generations, right? So first generation is machine code. Second is assembly, COBOL, C Basic, Cold Fusion, Progress GL, Oracle reports. So really, just memorize. We're going to start first generation language is machine code. It's basic, right? It's ones and zeros. It's binary, right? It's all it is. Assembly, again, we had short mnemonics, add, jump, sub. So it's starting to get a little bit more complex as we go up. Third generation, COBOL, C or BASIC. You're a COBOL programmer, you're in high demand because nobody does it anymore. Fourth, as we get more, you're going to look at typically GUI interface. So drag and drop. Rather than sitting down and typing out the code, you're going to do drag and drop and then export the code as a result.
So would source code be first or second generation?
It would be looking at third or fourth typically, right? Source, right? Because you'll have assembly code and machine code, or first generation is machine code, second is assembly, then third and fourth is where you're looking at that. So here's an easy way to understand. And if you just really understand the difference in the generations and kind of understand machine, it's really zeros and ones. It's really long and very difficult to program. Can you imagine trying to program something in machine code with all zeros and ones? Just not realistic, right? So as we come up and go through the different generations, you're looking at more repetitive with shorter codes. Now we got add this, sub this, jump to this, including commands, generators, and then fifth is that intelligent natural language processing. So when you look at that, kind of an idea, hex, right, is machine code. We're going to assembler, C, Fortran, C++, Java, Ruby. So as we go further up through the generations, they become more complex.
Go back one.
Yep. All right, that's kind of what you need to know. And I do remember you got to know really, I think the first, the generations and that top piece, machine, assembly, procedural, non-procedural, intelligent, and understand what each of those means. So I think if you were able to, if you memorize this chart here and understand and be able to tell the difference, that's really the critical piece of this. Kind of have an idea of, right, what the history of the different codes are. Just makes it a little easier to understand. I don't remember anything specifically about, is this C or C++, right? They're not going to ask you to that level, but it's kind of good to know kind of where they fall on there. Just to help you with the understanding the concepts. You don't have to be able to code in any of these, just know what they are and understand where they fall on the spectrum. All right, so computer-aided software engineering case. We're looking at, so it's programs to assist in the creation and maintenance of other computer programs. Computer-assisted software engineering. Hey, that actually kind of makes sense if you think about it, right? So a lot of this stuff, don't overthink it. If you know what case is, it's computer-aided software engineering, and the question says, which of the following utilizes programs to assist in the creation of another program? And one of them says case. You just need to know, oh wait, case stands for computer-aided software engineering. Got it, cool. So 3 types: tools supporting only a specific task in the software. Production process workbench is one or a few processes integrated, support one or a few processes activities integrating several tools into a single application. So you could have a tool that does a specific function, right? It's only going to do that one function. That is a tool, whatever that one function is. A workbench then says, okay, we're going to take these 3 tools that perform 3 separate functions and put them together into a single application. And then the environment is all or part of the production process with a collection of tools or workbenches. So when you look at this, we need to know case is going to be, right, a computer-aided software. What's the difference between a tool, workbench, and an environment? If you can memorize what's on that slide, that's going to be enough, and understand the difference. So if you see a question that says, in case, what is what supports all or part of a software production process with a collection? Well, I probably wouldn't go that deep, but right, you'll be able to understand. You'll need to be able to understand and look at this and say, oh, okay, a workbench is a collection of different integrating different. Oh, I'm trying to. Man, dude, coming back after a holiday is tough. Especially when you're not a developer. I was trying to think of a good example, and I'm just not I can't think of a good one offhand. Again, honestly, we'll go through these in the test. Yes?
Would an IDE be kind of a workbench? Because it's checking your code for different things, and it's bringing in suggestions for
No, I don't know. I'll have to come back because, like I said, I'm not a developer, right? So I'll be fully transparent on that. So this is one where I learned enough, right? This is kind of one of those tricks. Learn enough to pass the exam, and if I was going to be in development, I would dive deeper. This is what I needed to know to pass the exam.
I just pick up the environment, your garage. Inside your garage is a workbench.
That's a good way.
Workbench are some tools.
There you go.
Tools do smaller things. Workbench can do a little bit more because you got tools on it and the environment.
Your garage. That's a really good way of looking at that. I like that. There you go.
You might have to repeat it.
Yeah, no one.
I know. So in case you didn't hear that online, think of your environment as your garage, so it contains everything. Your workbench will have a collection of tools on it, and then the tools do specific tasks, smaller things. So you start with your tools, build to a workbench that can do more function, has more functionality. In the garage, your environment has supports the whole setup. Yeah, it houses it. All right, top-down versus bottom-up programming. Top-down, we're going to start with high-level requirements, the concept, and work our way backwards to the technical piece. Bottom-up, the other way around. We're going to start with our low-level technical implementation and work up to the final product. So think of this being, top-down. We're going to start with, here's what we want it to do. We're going to start with an interface. We're going to design our interface and work our way backwards on, here's the forms we want, here's all the functionality we want, and then work our way backwards to support that technically. The other way around, we're going to start building out and saying, here's how we're going to do it, and then at the end of the day, we're going to put that kind of the final product interface in front of you. So there's pluses and minuses to both of those. We'll go procedural C, top down, start with the main program, define procedures, work down from there. The other way, object-oriented, we're going to define our objects and then use those to build up. So if you're looking at a top-down, right, the user functionality typically will be a little easier because you're starting with what is the user looking at and then making it work on the back end versus a bottom-up being, we're going to start with that functionality and then finally get to that final product. But you just need to know top-down, we're going to start with the final main program. What are we going to see at the end of the day? And work our way backwards to make that happen. Bottom up, we're starting with the technical piece and working our way to that final product. Got it? Hey, open and closed source. Good to know. Closed source, proprietary, in an executable form. So source code is confidential. That's what you'll need to know. Think of Oracle or Windows. Right? There's a whole bunch of them, right? Open source, we're going to publish our source code publicly, allowing anyone to inspect it, modify, or compile the code themselves. So Linux and Apache. So just understand, when we look at closed source is executable form, source code is confidential. Open source is source code is publicly published, allowing for modification and compiling it. Look at closed and proprietary. That's good. I think I actually made that mistake. They're often used as synonyms, but not always true. Some open source is also proprietary. We then have freeware, so free of charge to use. So free as in beer. Anyone heard that one before? If you use it to use it any way you would like, including modifying it, it's free as in liberty. So gratis and libre, freeware is free as in beer, gratis, which is free of charge to use. So just understand free means, you could see it as gratis or libre. So free as in beer, meaning free to use, free as liberty, libre as in free to modify and use however you would like. Shareware is fully functional with a limit on it. So, right, what was was it WinZip? Back in the day, you could have the shareware version that was crippled after 90 days and then it popped up and asking you to pay for it that nobody ever did. I didn't ever do that because that would be wrong. But I've heard stories. Right, so you get a trial. Basically, you get a full full functionality for a period of time, and then it is crippled after that time, requiring payment to get full functionality. I'm sorry. I think crippleware is partially functioning proprietary software with key features disabled. So where you could download it to try it, but you can read and do stuff, but you can't save in certain formats, right? In order to really unlock all the reports, you have to pay for it. So you can see the report, but you can't actually do anything with it until you pay for it. That's crippleware. All right. Licensing, most software, closed and open source is protected by licensing. You very rarely see software that's not got some sort of license attached to it. We'll need to know the difference in the different types of licensing. One thing to remember, proprietary software, copyrighted. Right? That's typically copyrighted. So that's where you see the end user license agreement, where everybody just clicks install and I agree, that nobody ever reads that 47-page Apple EULA, right? Everybody reads that thing. Open source, there's a bunch of different kinds. The new public license, GPL, Berkeley's software distribution, and Apache. The most prevalent is GPL, which is on Libre software. So that's free to use and modify as you'd like, right? So basically the core, copy left, get it, copyright, copy left. Security is fun. Come on, security jokes. All right, copy left, ensure free software remains free. Ideally, right, at the core of it, it says if you're going to use and modify, you just need to credit the original person that you're using it for them, right? You can't change it without giving credit where it's due. So I understand proprietary software, if you see a copyright, most likely it's going to be proprietary software, then copyrighted. Open source, GPL is the free to modify, change, and use and share as they like, assuming they give credit where credit's due. Right? You'll see that where they say, yep, you can use this code, but you have to give credit, and then somebody will put it into their proprietary software and not credit them. And that's where they get into trouble for violating the license. They'll use like a snippet of code or something. All right. Just understand kind of where those differences are. Everyone got open and closed source and the different licensing types and memorized and ready to go, right? All right. So now the development method. So waterfall. Again, here's what you need to know is on the slide. Linear, rigid phases. One phase ends, the next begins. Right? So goes back to predating software design and used in manufacturing. Unmodified waterfall does not allow developers to go back to the previous steps. So if you get to implementation or verification, you can't just circle back and go back up if you missed something, right? And this you would have to just start over again because you can't, no iteration. Whereas your modified waterfall allows you to come back and address it to using verification and validation of user requirements, okay? So that you see the waterfall is very rigid and linear, well-structured plan, requirements to be followed. Modified waterfall, verified and validate user requirements for every phase. That's the key differentiator between those two.
Does that mean there's no patching?
This is for development, not for like the maintenance, the ongoing. That maintenance piece, that would be once you get it in, that's in maintenance. Yeah, that would be included in the maintenance. This would be saying waterfall would be, here's our requirements, we're going to build this system. Okay, now we're going to design the system. Now we're going to implement that system. If we get to implementation and we find out we missed something, we got to go back and start over and go back through, right? There's no circling back versus with the modified, where you can go and do your verification and validation and then kind of step back up and make sure it gives you a little more flexibility, right? Waterfall, very rigid, structured. Modified waterfall, verify and validate user requirements at the end of each phase. That's a big differentiator between those two.
Big point also is in the modified, you can only go back one step at a time. You can't go from maintenance all the way up to design.
Right. Right. Yeah, good point. Okay, so that's what you'll need to know for the difference. That slide that's on there, that graphic, and understand that. That's everything you need to know about those two methodologies. See? mile wide, inch deep. Sashimi is exactly what it sounds like. Think of the fish, right? It's what it's named after, highly overlapping steps. It was based on in reaction to waterfall, so overlapping layers of fish, right? That's easy to remember. Sashimi, it's exactly what it sounds like. If you know what the food is, that's what it is. Yeah, hardware design model used by Fuji, Xerox. I don't think you'll need to know that, but yeah, it's overlapping steps. So we're working on multiple things. So we're going to do our concept and begin our requirements analysis at the same time. And then we start our design based on as we're working through it. So we're not doing hard, rigid steps. Each step overlaps. There you go. Sashimi. Fun to say. Spiral. 1986 paper, spiral model of software development and enhancement. That sounds really exciting. I'm not a developer. So we repeat the steps of a project starting with modest goals, expand outward, right? So each step of the spiral or each round constitutes a project. That's important to understand. Each round can be a different sort of development methodology, and you do a risk analysis with each round. So I'll bring this up. When you look at this, right, I'm going to try and remember to use my laser pointer so that people online can see what I'm pointing to. So we start, and as we go around each spiral, as we get around, that's a project. So you could have waterfall to this step. You could have it in another waterfall around, right? So we're looking at each step or each spiral is its own project. And each spiral or each project or each round could be its own development methodology, whatever that is. So just understand, right, kind of the seashell. We're going to go in spirals, and each spiral is its own project.
How does this incorporate security more than the previous one?
So you're going to be doing a risk analysis on every single round. So you're going to be including that risk analysis versus, right? So you look, we're going to do a risk analysis prototype. That's what I was trying to think of earlier with extreme prototyping. It all ties together. Concept, requirements, life cycle. So then we start over with our risk analysis. We prototype it again, right? So now we're going to be evaluating the security, involving it in each round, each project, versus if you go back here, we're just building through it. Now, security should be included in each one of these steps, but we're not going through these steps multiple times to get to a final project. Does that make sense? Sashimi, you'll still go through kind of linear. They overlap. Versus, this one we're going to do multiple rounds of it, and each round we're going to do that risk analysis part.
So you're essentially just iterating more or less every spiral.
Yep.
Just to see for any problem.
Yep. Iterating every spiral. Exactly right. That's what you need to know. There you go. Everybody's ready for their Domain 8 exam now. All right. Agile software. This was the reaction to rigid. So this is the exact opposite. Scrum and extreme programming. Agile manifesto. If you look, really, it basically is calling out the old school way of doing it, of being very rigid, right? Individuals and interaction over process and tool, working software over comprehensive documentation, collaboration over contract negotiation, and change over following a plan. So it really is saying we're going to be agile and just make this happen. We'll come back and but whereas with waterfall, you've got, we're going to do this, we're going to do this, we're going to do that. There is no flex on that here. Yeah, we're going to make the interaction work more than the processes and the tools. Okay. So when you look at Scrum, named after rugby, right? Everybody familiar with rugby, what the rugby scrum is? When they put the ball in the middle and both teams come and it's just like chaos. So you get a small team of developers called the Scrum team by a Scrum Master, and the product owner is your voice of the business unit. So when you get a Scrum, it's going to be a small team that says, you know, here's what we're doing, here's what our goal is. We're going to work as a team. Go. They're going to work together. You've got the Scrum Master who is going to kind of provide that guidance for them, right? And then you've got your product owner getting involved in saying, hey, here, yes, no, does this meet our requirements? What do we need to do to change it? So just understand a Scrum, small team of developers called a Scrum team. Scrum Master is the coach. And then your product owner is the voice of the business unit. That's all you need to know. See? It's not hard. A lot of memorization if you're not a developer. But, again, we don't need to know the exact in-depth pieces of what goes into a Scrum team, what are the different, right? We just need to know, hey, if you see Scrum, think of rugby. Just a group of people doing what it takes to get it done. All right, extreme programming. So difference here, both are agile. So again, you'll need to know if you see Scrum or extreme programming, that's agile versus, you know, waterfall or spiral or sashimi. Those are the old linear ones, right? Difference between Scrum and extreme. Extreme, pairs of programmers working on a detailed specification, very high level of customer involvement. So at the core of it, right, we're going to see planning, paired programmers. It's based on a 40-hour work week, which would be awesome, right? We all work 40 hours and that's it, right? But ideally in extreme programming, that's what they're saying. If we're putting in overtime on that pair of programmers, we've got a problem. There's a flaw in how we're doing this, right? That's kind of a core of extreme programming. Customer involvement, customer is always available, and then detailed test procedures called unit tests. So on this, really what you want is, you know, planning. So it's the user story. That's your determining your iteration or your timeline, driving those specifications. Just understand, again, if you see, you know, this development methodology includes user stories and unit testing. Oh, okay, that's extreme, and pairs of programmers, right? That would be extreme programming. You don't need to know any more than what's on here for that, right? It's good to know. Let me rephrase that. I don't want to undersell this. It's really good to understand the concepts behind it, right? But if you study this and understand where we're at on this, this will typically be enough for you to understand and be able to parse out what they're looking for, right? You don't have to be an extreme programmer. You don't have to be a developer in Ruby to understand and be doing extreme programming or Scrum or rapid application development, okay? So rapid application development, software via the use of prototype, dummy GUIs, backend databases, and more. So this is where you're going to have you need to quickly meet the needs of the business unit. How you're actually going to do it, kind of secondary, right? How good the code is going to be a secondary one. Where you would see this is where you've got a customer saying, I need a program that does this. And they don't really understand what it's going to look like. So you're going to throw up a prototype and then work your way backwards, right? So this is going to be very, think of it like prototype dummy GUIs. We're just going to throw things out there to kind of see what's going to work. The technical specifications are an afterthought. We're going to just put stuff out there, see if it works, and then we can go back and implement one of the other methodologies once we understand what exactly they're looking for.
Still fall under that, like agile?
Yeah. Well, you know what? That's a good question. I would think it would. I think I'm trying to remember back.
It's like prototyping is actually
It's very,
doable.
yeah, it's really agile in terms of, well, but if you think about it, right, it's customers heavily improved. We're just throwing things out as quickly as we can and then changing it, throwing out another prototype. Okay. Mocking up a website. Is this what you're looking for? Okay, that's not, okay, let me throw up another mocked website and this is what it would look like. Okay, now, once you get that, now we're going to go back and actually make it work. All right, so, man, I don't remember. Yeah, I would consider it,
Technically a part of Agile.
Yeah.
Agile, there's 5 columns under it, this is not.
Yeah, I would
But
say
it's similar in the fact that it's flexible.
similar and flexible. I was going to say, I think Agile is just, would be the Extreme and Scrum and yeah. So yeah, prototyping, what that is, iterative approach, breaks down projects into smaller tasks, creating multiple mock-ups, lowers your risk by allowing the customer to see realistic looking results long before the final product is completed, right? So when we look at that, here's what that would look like. You don't want to, you know, how many people have said, right, oops, I don't know if they can see that or not. Right, so we go and they come up and they say, I want to do this. Well, what the developer sees and what they see in their head are going to be very different, right? Often. So they'll throw together and mock up that prototype and then go from there and revise it. Okay, now we've got a version 1, version 2, so on until we get the final product. So when you look at this rapid application from concept to final, you know, 2 to 6 months. Right? We're going to be each one of these phases, each one of these versions is going to be 1 day to 3 weeks. So very quick, short turnarounds, mocking up and trying to go from a, you know, that wide, here's developers on this side, the users on this side, or the customers on this side, and coming together to make that working product. All right. Questions on that? No. All right. System development lifecycle, so SDLC. On the exam, SDLC focuses on security in every phase. That is a core piece of this. We're looking at not any particular application development model. This is the entire system, right? How are we going to select it? What is the process for selecting it to all the way to disposal at the end of the day? So how are you going to sunset it when we're done? So SDLC, security at every phase, looking at wider than just any one of those particular application development models, right? Because it's going to include those resource requirements and disposal. If you looked at those development models, thunder's going, yeah, they don't cover all that information. So SDLC NIST 814, to prepare a security plan. There we go. Starts with it at the very beginning. Ensure security is considered in all phases of the system life cycle. Those phases, initiation, I need this. I need something that will do this task or this process. Development acquisition, we're either going to design it or we're going to go out and find software that is already built to do that. Implementation, we're going to actually test it and then implement it. We're going to install it. And then we have operation maintenance. This is the best part. Modified by the addition of hardware or software, disposal, security, decommission. Okay, that's what NIST 814 says. In reality, it's been withdrawn in its entirety. So gives you a good overview of what that would look like, but it's not actually used. It's been withdrawn. So there you go. So when we're looking at it, look at, yeah, I agree with Evan. OWASP, Secure Development Secure Software, SSDLC. Again, it's going to give you a really good idea. So here's kind of a breakdown of this. So again, what you see here, you don't have to worry about all the specifics under each of these phases, but understand the flow, okay? So we're going to start with an idea. Ooh, I need something that will do this, whatever this is, okay? Now we're going to come up with that concept. What is that going to look like? We're going to define the scope. Then we're going to plan how we're going to do it. We're going to do our requirements analysis. Okay, what do we need to make this work? Design or acquisition, right? We're going to take the concept, the requirements, and we're actually going to design the software to meet those needs. Developing it, integrating it, testing it, implementing it, operations, maintenance, and disposal. So just understand the logical flow of it and how would you consider security in each of these different steps, right? We want to make sure that security is included. All right.
Going back to that, OWASP, OWASP.org,
Yeah.
great cheat.
Yeah, OWASP has a ton of cheat sheets. It's a fantastic resource. They've got some really good stuff out there.
They got a pretty good podcast.
Do they? I can't actually listen to that one. I'll just add it to the list with all my spare time. Okay, so again, from a system development, right? Again, the biggest thing to remember is it's broader than any one of those development models, and it's going to cover it from initiation to disposal and includes security at every step. As long as you can kind of pick that out of those questions, you'll be in good shape. Software escrow, talked about that. It's having a third party store an archive or computer software in case the developer or that the company goes out of business. Concerns, right? Orphan software is when that happens, when the company goes out of business. They're no longer receiving security updates. That's a problem. So that software escrow places the source code with an independent third party or a neutral third party. And then you'll have a contract that strictly specifies the conditions for potential release. And typically, business failure of the software vendor. So just understand what software escrow is. Neutral third party controls it with a contract that strictly specifies conditions for release. There you go. See, everybody's still awake. We're 7:30. Flying through this. Go faster. Code repository security. So think about, code repositories, GitHub, right? Everybody's familiar with GitHub. Concern, accidentally publishing private code as public is common mistake made by developers. Could be publishing code that includes passwords or private keys. So there's a really good story on page 448 where the guy published his Amazon password somehow. He thought he was publishing it to private, and there was a bug in whatever he was using, and published it to it went public, and they racked up like a $6,000 bill in like 30 minutes or something ridiculous, like before he could realize it and shut it off. So you just got to make sure that's a concern of publishing to code repository. APIs, application programming interface, allow an application to communicate with another application, operating system, database, or network. Okay, so problems with this are pretty bad, right? Hey, we've got this API that allows you to interface with our software, but then they don't have any controls in place, and the API actually allows you full access to everything on the back end. There's no sort of access controls in place, things like that. There's a lot of times no security testing that would render them secure from attack. So like think of a web application that has an API call. Well, if you've got that exposed so that other applications could connect in, what controls do you have in place to prevent privileged execution or the ability for us to see everything on the back end, right? Should be write only, so you can only update, but we can actually see everything. We can read and pull things down. So yeah, the OAuth API, again, OAuth, really good resource. All right. So software change and configuration management, similar, but separate in the exam. So configuration management is changes to specific piece of software. Change management is changes across an entire software development program. So configuration management is the configuration of a specific piece of software. Change management is across the development program, so all of it, right? So we're looking at one piece versus changes to the environment as a whole. All right, does that make sense? I don't want to be skipping through this too fast if you guys are confused. All right. Sorry, people online. The people here said that we're good, so we're moving on. You can blame them. NIST 800-128 is configuration management. Configuration management plan is going to have comprehensive description of roles. This should look very familiar to change management, right? Basically, like, I think it's the same thing, just for a very narrow scope. It's for a specific piece of software. Configuration control board as opposed to a change control board. Configuration item identification. So what are we going to be doing, right? Configuration control board is the same thing as a change control board. We're going to be looking at approving what the responsibility is and who's going to be doing and approving these changes to the configuration. Configuration change control, what's the process for managing the updates? Configuration monitoring, how are we testing for compliance? So how do we know what's going on? Are people making configuration changes without going outside of the process? How are we monitoring? That's what monitoring is, looking for those things. All right.
Special club 800.
Yes, it's a typo. No, there's no typos. You're just reading it wrong. We're perfect. Never. It says 800 in the link. All right. Sorry. All right. So again, I just know the difference between configuration, change management, and configuration management, right? Configuration, specific piece of software. Change management, the entire suite. Think of the larger.
Does anybody do two different?
You should have.
Configuration.
So you would have.
Most places just have change
management. I would say most places probably just have change management, but
and then everything, whether it's a configuration or a change,
would go through that. Yeah, but for the exam, I would say just know the difference between configuration and change. Yeah, in reality, I would say you're right. At most places, it's one and the same. Probably, I would say probably development houses, like actual software development companies, probably do have that specified out differently, but I would say I've not seen a configuration management be separate anywhere I've worked. It's always been one and the same. DevOps, so separation of duties between developers, quality assurance, and production, right? So we want to make sure that we have separation between, so one person can't make the change, approve a change into the software, and implement a change and hide a backdoor in, right? So we have somebody doing the actual development, somebody else doing quality control, somebody else actually implementing the change into production. So you can't have one person hiding something as they go through the process. The actual definition there, practice of operations and development engineers participating together in the entire service life cycle. But yep, that's what DevOps is. There you go. No, I can see if people are like that's kind of the highlights of what you need to know about this, right? There's a lot more to it. Don't get me wrong. There's a whole lot to DevOps. But what we want to know is understand is it's that separation of duties. during the life cycle. So developers to QA to production, so that one person, I couldn't write the code that includes a backdoor later for later use. Do QA on my own code, say, oh yeah, it's perfect, there's no problems. Or even if it's unintentional too with bugs, and then I'm not implementing that code, right? So we're splitting that off into separation. They don't have one person doing all three phases. All right, object-oriented design. Objects, metaphor to design and write computer programs. So when we look at this, object-oriented programming replicates the use of objects in computer programs. So we'll go through that a little bit more, but this is that black box. I'm going to define an object. This object is going to have code within it and data. We're going to input a message. We're going to take in a message. We're going to process it. The whole point is you don't see what's actually happening in that object. And then it's going to, based on whatever that code is within it, it'll send out a message appropriately. And you use these objects throughout. So you define the object once and you can reuse that object. Object-oriented design, higher level, think of the flow chart. Right? So we're actually going to be designing how this works. And then the object-oriented programming is actually taking that flow chart view and making it happen. So again, program is a series of connected objects communicating via messages. Attempts to model the real world. So you get something in, you process it, and something else goes out. But once you define whatever is happening in that box, you define it once, and there's that code in it, and you can reuse that code repeatedly. So rather than that linear code that we had before, we just do the code, that object once, we define it, and then we can reuse it to do, perform that task again and over again. Like, I'm trying to think what the example was we talked about. So object-oriented programming, you could have, well, hold on, I don't want to get ahead of myself, hold on. So, yeah, objects contain data and methods, what they perform, and then encapsulation, data hiding. We don't actually see how that object is performing the function, right? We can't see it, we just know it's coming in, and then it's going to spit out a result based on the programming within it.
Where you get the box.
You would define that object, right? So hang on. There's a slide here in a second, and I'll show you that.
And then you do know it's the box.
The developer does, but from when it's executed, we actually don't see, right? So if you're looking at it, you'll just see the object called as opposed to linear programming. So it'll make sense here in a second. That's my problem. I tend to get ahead and then like, wait, we're gonna go through it. So hang tight. Concepts for object-oriented programming: object, method, message, inheritance, delegation, polymorphism, and polyinstantiation. Do you remember this from the database piece, right? And viruses, right? So inheritance, we're reusing code of existing objects and establishing a subtype. So think of it, right? Inheritance would be if you have auto parts. If you're ordering it online, right? You have the year, you enter your year, and then that brings down your inheritance. So that year, these were the makes of cars that were available. So you choose Chevy. Well, and then you have another one that inherits the year and the make, and here are the models that were available at that time. And you pick a model, and that next box is trim level, and that inherits those previous ones, right? So it kind of builds down, right? We're taking subtypes of those higher levels. And same with a delegation. So you could have an object relying on another to provide a specified set of functionality. So we could say, if this happens, we're going to delegate the task, right? A delegation is pretty straightforward. Everybody's used delegation. If not, you're doing your job wrong. Totally delegate it. Makes your life easier. I need Joe to do this based on the fact that it looks like real work. All right. Polymorphism, so ability to create a variable, function, or an object that has more than one form. So we can have multiple, based on what that comes in, we're going to have different forms for it. Think of that, like I always think of that as like with the viruses, right? The polymorphic, it changes dependent on what we're at. So you can have multiple forms for that. Polyinstantiation means many instances. So you can have two with the same name that contain different data. Right? This is from like database where you have multiple entries that have the same. How do you differentiate between them? So you can have polyinstantiation. So if you look at this, and I have to speed up here. Right? So you have object one, another object. So we send a message across. Depending on what that message states, we may have multiple methods, right? This is the different functions within it, and then additional data. So we don't know exactly how that's going to be processed once it's coded, right? Because it's hiding what it's actually doing. But it'll take this message, process it based on the different methods or functions, and use that data and send out a message as a result. And I think object-oriented, I think flowchart. Really, at the end of the day, that's what it comes down to. Coupling and cohesion, you will need to know these for sure. Just using these to describe objects. So highly coupled requires a lot of other objects to perform your basic jobs. And high cohesion is independent. It can perform functions independently. So in this case, right, whatever module 1A is going to require D and E to actually perform its task. Right, so we've coupled it, but A and B are cohesion. They're independent of each other. Right, they don't require each other to function. So when you see this, we just need to know a coupled object requires other objects to perform its function. Cohesive, high cohesion is independent. And that's just a memorization thing, right? That one always tripped me up because I'm like, cohesion, why? But yeah, it's cohesive. It's all it's tight together. It doesn't need other pieces to actually function, right? It's one cohesive
So for
function.
me, I got married, I'm part of a couple, because otherwise I wouldn't function.
I will save you getting in trouble and not repeat that online. No. Yeah.
Well, that's just fine.
Yeah.
I think my wife has a t-shirt with that phrase on it.
That's funny. So I got married. I'm a couple because I couldn't function without the other. All right. Okay. So coupling and cohesion. Make sense? You just need to know the difference. Coupling, I need other pieces I need other objects to complete my function. Cohesive, I'm independent. Object request brokers, locate key objects and think of it as an object search engine, okay? So middleware, this is when you would see COM, DCOM, or Corba, and we'll go through those very quickly. Right, so here's your object request broker. I've got this application. Hey, I need to find this service. It'll function as that middleman to activate it on the remote and help you establish that connection. What do these look like? Corba, Common Object Request Broker Architecture, Open Vendor Neutral Network Object Broker Framework. So Corba is the open version and competes with proprietary DCOM. Okay. Same basic functionality, which is open versus proprietary. Right. So this is what this would look like from that standpoint. So you've got your object request brokers in the middle, acting as that middleman between the client and server. So really, CORBA, networked object broker, separation of interface from the instance. There you go. All right, object-oriented analysis and object-oriented design. So this is the design methodology that takes it higher up. So, right, draw a flow chart on the whiteboard, which is how this should work. That's your object-oriented design. And the way that it is actually going to flow and manipulated. And then object-oriented analysis is looking to understand or analyze a problem domain. So what are we trying to fix? How are we trying to address this? We're analyzing what the problem is. We're then going to do a whiteboard of the flowchart of how that design is going to address the solution. And then we take the object-oriented program and actually code those different boxes in the flowchart. Does that make sense? So object-oriented analysis, we're going to analyze the problem. Design, we're going to design a solution. We're going to whiteboard it. We're going to do a flowchart that says, oh, if this is our problem, here's how we get to that point. And object-oriented programming is actually going to be programming the functionality of those different flowcharted boxes, for lack of a better phrase. Yep. Software vulnerability testing insurance. So CWE stands top 25, the biggest ones. I don't think you need to know all 25, but some examples: hard-coded credential, buffer overflow. You will need to know SQL injection, directory path transversal. We'll go through these a little more, but yeah, hard-coded credential, you leave your username and password in the code. Okay. Buffer overflow, you're not going to do a variable balance check. You're trying to overflow, right? Outside, well, we'll go through it. Outside of maybe you should only have first name, last name as the field, but you don't perform any variable checks. So you enter in 500 characters. Well, it's going to create a buffer overflow. We should put a variable check of 15, 20 characters, whatever it is. SQL injection is going to be the manipulation of your backend SQL server via the front-end web server. So we're going to inject SQL commands through the web server to manipulate the SQL server on the back end. And then directory path traversal is where we can actually get out of root and into the file system. PHP remote file inclusion. So we're going to take our URL, right? So file is readme.txt, and we're going to actually use it to execute remote command. So in this case, it would be the bad PHP. Cross-site scripting, third-party execution of web scripting as a JavaScript within security context of a trusted site. So we're going to run malicious script within a trusted site. And then cross-site request forgery, third-party redirect of static content within the secure context of a trusted site. Just, there we go. Memorize those. So buffer overflow, we're not performing balance checking, right? So a lot of the languages C don't include it. Also here it is called smashing the stack. So there's your variable username should be, a balance check of 20. It's going to print out enter username, get string username. If you don't have a balance check on there, you could put in however many characters you wanted and crash the system, right? Create a buffer overflow. Can't process it. Time of check, time of use, the race condition. So we're going to alter condition after it's been checked, but before it's used. So in this example, the file test is readable by the user. Open the file test. If not, cannot open file, right? So that's our check. So what is the race condition? It's going to check to see if the file test is readable by the user. Well, in that case, what the attacker is going to do is say between steps 1 and 2 on the top, I'm going to run these other processes because I've got that time of check. Can this happen? Yes. Okay, I'm going to run these things before it actually occurs. So time of check, time of use. Or a race condition, right? So again, alter a condition after it's been checked, but before it's used. disclosure. So this is where we're talking about what a security researcher does after discovering that a vulnerability. So full disclosure, that's not always liked and kind of controversial, right? That's where they're going to go to the public and say, hey, this is out there, that you better be aware of it, right? The thought being, if the bad guys may have it, so let's just make it so everybody has it. This has been trying to ensure and pressure the vendor to patch the vulnerability. I think, right, when you hear this, this was, what was the example? Panera, right? They went with responsible disclosure. They found the vulnerability, went to Panera, and 6 or 9 months later, the vulnerability was still there. Panera hadn't done anything, so they went and fully disclosed it to the public. Right? It's pretty controversial, right? Because now you've publicly made this available. Whether or not bad guys knew about it, they do now. Thought being, we're going to pressure them into actually taking action. Responsible is going and sharing that vulnerability information with the vendor and then not releasing it until the patch is available. So there are other options, but those are the two most common that you'll see. All right, everybody got disclosure? Full is controversial. Responsible is going to the vendor first and giving them a chance to actually address the vulnerability. All right, database. Need to know this. Database is structured collection of related data. All right. No, that's actually more. Okay. You have relational database, hierarchical, object-oriented database. And then the simplest is a flat file. So text file that has multiple lines in a standard format. Kind of, like CSV is an output of a flat file that could be in there, similar to that. Flat file model, right? It's just a text file. Hierarchical, exactly what it sounds like, that tree, right? It's a hierarchy. Relational, that's Microsoft SQL Server. It's relational database. That's the one most people are most common with. You can have object-oriented, very similar to object-oriented design or programming, and then a network model. So as we talk through these, relational, most common, two-dimensional tables of related data. Columns and rows, you need to know the difference. When you see this, that a row could also be called a tuple or tuple. It's getting late. And a column is an attribute. You will need to know, because they'll say a tuple and an attribute as opposed to row and column. So I will test you on that and know which is which. And then the single cell where you have that intersection of the row and the column, that's the value. So you'll need to know that as well. And then you have to have a primary key in each tuple in a table. So each row must have a primary key. There's more, don't worry. You guys excited? Databases are fun. All right, relational database, you could see, right, employee table, so you could have social security number as the primary key. Your attributes would be would be social security number, name, and title. Tuples in each row would be the different values. And then graph would be an example. So let me pull this up, right? So in this case, we're going to have social security be a primary key because it's going to be unique, right? So here are each of the tuples is the rows. Graph is your value. That's where your row and your column meet. Okay? And then you can have two tables in a relational database joined by a primary key. So you would have Social Security, SSN, in multiple tables and then the additional columns could be different, but you'd be able to tie those together off of that primary key. Make sense? Okay. Foreign key, key in a related database table that matches the primary key in the parent database. So that's where you would have your primary, the foreign is how it's going to match up with your primary. That's how you're going to tie those things together. You will need to know referential semantic and entity integrity. So referential integrity means the foreign key in a secondary table matches the primary key in the parent table. That's it. So referential integrity means you know if you're doing a referral lookup there is a one-to-one match in each of those tables. Semantic integrity means the attribute or column value is consistent with the attribute or data type. So if you think about that being, is it a text or is it a date format or whatever it is, your column value is going to be consistent. And then entity integrity is each tuple or row has a unique primary key that is not null. That's a memorization piece. Know those differences. Normalization, we're going to remove redundant data. At the end of the day, that's what normalization is talking about, right? 3 rules. Divide your data into tables. Move your data that is partially dependent on a primary key to another table, and then remove any data that's not dependent on the primary key. So those are your 3 rules for it. But database normalization, really what you want to look at is it's going to organize and remove redundant data. We're going to normalize the data. We're going to remove that redundancy out of there. Your database views, so this is a query result can be called a database view, right? So this is where we're going to lock down who can see what. We can constrain what users see based on a database view. So I could say, right, David can see in the database, he can run a report on his employees, and that's David's view is the name of the query, and that's what he sees. It's constraining that the result of that query being right what you're looking up. Data dictionary. All right, that's your description of the database tables. Okay, so this is your metadata, right? Data about your data. It's who's information about authorized database administrators, user accounts. It's really the database schema, right? This is the core of what your database is all about. What's the view? Who's allowed to see it? Who are the administrators? What are the attributes and values of the tables? What's allowed in each of these things? So that's really setting the table of saying, here's how our database is structured. There you go. Data dictionary. All right. Database query languages. So this is allowing creation, read write, or a lot of other functions. So we need to know we have data definition language to create, modify, and delete tables. You'll need to memorize that. Which of the following is a lot used to create, modify, and delete tables? Data definition language. Data manipulation is using to query and update data stored in the tables. Right? So we're defining the data, right? Create, modify, or delete the tables. We're defining what can be in there, and then manipulating it, so we're querying it or updating it. Most popular is SQL or SQL, IBM in 1974. There's a whole slew of them out there. You don't really need to know any specifics about it, just that structured query language is the most common. So you'll see, right, common SQL commands. Anybody who's done anything with Microsoft SQL Server is very familiar with these. So I just understand, right, create, select, delete, insert, and update. So if you see a database query language that's looking for which of the following types of database uses create or select, delete as examples, it would be structured query language SQL. And relational. Anyway, hierarchical think of DNS, right? It's a global tree. We're going to start with a authoritative and then spread our way down. So hierarchical databases is DNS servers. There's other examples, but that's probably the easiest one and what you would see. Yeah, object-oriented databases, same thing, very similar to your programming, right? Contain passive data. Object-oriented databases are going to combine data with functions in that object-oriented framework. So typically, right, relational databases is just rows and columns of data versus an object-oriented is going to give you your data and function code in that framework. So again, I think of it as the same. If you understand how object-oriented programming works and think of that, similar for object-oriented databases. It's going to have functions and code combined to actually execute and work together. All right. Whew. Database replication. Mirroring a live database, simultaneous read and writes. Multiple replicated databases by client. So database replication mirroring is, right, we can read and write to multiple databases by multiple clients. Shadowing, very similar. Shadowing, you only see the primary, and then it's copying to the set to those mirrored. It copies the changes across. So database replication, you're gonna have multiple live databases that can be accessed. Database shadowing is going to be copying the changes from a primary to that secondary, to the mirror. Okay, does that make sense? Very slight difference between the two. Very similar end result. You're gonna have two up-to-date copies of that database. All right, data warehousing. Yeah, large collection of data. It can be terabytes or petabytes. Once you get it in the warehouse, lightning's getting pretty fun out there. That's gonna be a fun drive home. You use data mining once it's in the warehouse. Data mining, looking for patterns, right? What's the big warehousing and mining right now? Is it still Hadoop? Is a really big one for big data, right? It's where you hear big data. We're going to collect all this data and then look for patterns in it. That's the data mining, is looking for those patterns. So artificial intelligence, we're trying to program computers to think like mammals, right? Think of that intelligently. Think of it as mimicking a mammal. When you're looking at expert systems, two concepts: knowledge base, if then, right? So if this happens, then this. If you see this, then do this. And then the second is the inference engine. So it follows a tree formed by the knowledge base. So as you build out this knowledge base of things that happen, it's going to follow the tree and say, if this, then go to this. If this, then go to this. And it's going to follow that tree down. So really, with expert, you really need to make sure, integrity of your knowledge base is critical, right? So if it's following a tree to make these decisions and you don't have integrity, it could really mess with the end result, right? You could get somebody in there manipulating it and get results you don't want. But yeah, the entire knowledge base is going to follow a logic tree trunk. It's going to then branch out. So think of it as, right, we're going to start here. If this happens, then what? Okay, if that happens, then what? So you kind of start spreading out based on those if-then statements, and it'll eventually end up somewhere with whatever end result you want.
So would those expert systems, would a good example of those be a lot of the automated help agents you get if you visit tech support?
Yeah.
Like, tell me about it. It sounds like you're talking about this type of problem.
Yes. Yeah, I think that would be a good one. The other one could be almost like the IDS IPSs too, right? If you see this behavior, then look for this. If this happens, then look for this. So it's going to look for patterns that it knows about and make inferences based on that. Artificial neural networks. So it's made to simulate the neural network found in animals or humans and animals. Where it's going to take an input, make a decision, or make a process it, and then take those inputs, make a decision. It's trying to simulate a brain, right? Really, that's what the end of the day is. So how does that work? Well, we're going to take, here, I'm going to kind of skip ahead here. I'll go back. But really, we're going to take all our inputs. We're going to take those inputs, and based on those, we're going to put an output in place, right? So that at the end of the day, that's what we're looking for. So artificial neural networks, replicating biological neural networks. You receive an input and send an output when you hit that certain layer. So artificial, I think this is a good one. Predicting the weather. We don't need exactness, but I'm going to take in all these different readings from the wind sensors and from humidity sensors, and those are all our inputs. We're going to process those, and based on what we're seeing coming in, we're going to kind of say, okay, right, we think based on the input that you're going to see temperatures of this. You're going to see thunderstorms because of the inputs. Okay, so artificial neural networks, kind of fuzzy. It's going to take multiple inputs, and try and narrow it down to the outputs. It's replicating, trying to replicate human brain.
Wasn't Google's AlphaGo a neural network?
It was Alphabet, and what was it?
AlphaGo.
Maybe? I don't know. I wouldn't be surprised. I know they've done some stuff. I don't know what one it was or what it was called.
Yeah.
Sure, we'll go with it. It's late. All right. Bayesian. This is typically for spam, right? We're going to put a mathematical formula for calculating conditional probabilities. So we're going to say, we're going to look for a certain token, right? In this case, so everybody familiar with spam filtering, right? We're going to take certain words and we're going to assign weights to it. And then we're going to say, based on this, the probability of this being spam is 0 to 100. So based on those tokens and what the weight is, we're just trying to apply a mathematical formula to that to figure out what the probability of it. So Bayesian filtering is looking at, think of that as spam filtering, right? We're going to read it, look at the words, apply a weight to it, and give you a probability of this being the case. All right. Questions on that? No? All right. Genetic algorithms. So this is pretty cool. It's where it's replicating or attempting to replicate evolution. And so it's going to create software programs based on like breeding and applying mutations, evolution, right? It's kind of cool. It uses Lisp source code. I don't know. Anyway, kind of interesting that they use that. I don't know what that is, why they would call that out. But anyway, genetic programming, entire software programs, short pieces of code, shockingly called chromosomes. You're going to create random programs, assign them a task of solving the problem. They'll figure out how well they performed at their task. They'll then they'll breed two programs together, right? Swapping code, breeding, and then add random mutations. So, right, we're going to say, what are we trying to do, right? Here, the good one, Pac-Man playing program. We're going to say, we're going to develop these random codes, see how well they play Pac-Man. We're going to take the best ones and create those and breed those together. And so then we take the best parts of the codes that work best together and see how those work. And then we'll apply random mutations or random changes to the code and see how that works. Right? So it's genetic algorithm programming. It's attempting to emulate evolution. Skynet. There you go. Woo!
Good job.
Man, that was exciting stuff, wasn't it? All right. Next Thursday. I'm sorry. The next class on Thursday. Sorry, it pops up that I have a low battery. We are going to work through the practice tests. Right. We're going to go through kind of understanding the thought process behind how do we read and how do we know what they're asking. So read, come with questions, and start memorizing. There you go.
Will you have a list of test prep resources?
Yeah, so one thing I'll mention, we'll bring it up next week, the FRSecure.education, which is what I used. It's Clement Dufois, if I'm not mutilating his name. He's been around forever, and he's really been big on this. And so that's the test prep that is the engine that we'll use, is what I use. And he's got a code that he'll give you guys, or that we can give you, that'll get you 25% off any subscription. So, but it's a really good resource to just get you in the mindset of how to take the exam. So.
Does his tests include the information just released?
It is, so it's user submitted questions, right? So members of the site, right, for CPEs, you can submit questions for consideration. So it'll be user submitted. So I would say it's pretty accurate. There are some that are older.
Does this fall under the realm of brain dump?
No. Nope, because you will not see test questions that are on the actual exam. You'll see similar types of questions, but you will not see the actual questions that you would get on the CISSP.
Perfect timing.
All right.
Yeah.
Thank you. Thank you, everyone online.